We are in Introduction to Statistical Learning, and we're on Chapter 9, and we're just starting the applied questions, so question 4. Okay, so here's the question. So we're going to generate a data set with 100 observations, and it's going to be it's going to have two classes, red and blue, and there's going to be two predictor variables, x1 and x2. And then we're going to try to classify those observations appropriately as either red or blue according to the predictor variables, x1 and x2. And for that, we're going to use different versions, I guess, of support vector machines, although, the first one is going to be linear, so it's, well, anyway. So we'll start with a linear classifier, and then a polynomial, and then ultimately a radial basis kernel. Okay, so first thing we need to do is to create some data here, and so you can see how I've done this, and you can, there's a lot of ways to create this, but then I'm going to break it up into a training set and a testing set, and then I plot it, and so I've already done all that, and so this is what it looks like here. Okay. And so the first thing we'll do is to try to separate this with a linear classifier. Now notice that we can't really perfectly split this with a linear classifier, right? However you try to draw a straight line, we're going to be making, some misclassifications for sure. And so we're just trying to find the best line here, okay? And so we'll install and load the E1071 package. Okay. And I'll run this again, so we want a model. So here's our model, and we could use the SVM if we were already sure of what we wanted the cost argument to be. But if we use the tune function instead of SVM, then R will go through and check every one of the values that we give for cost. It will check each of those. And then roughly do cross-validation on those, I think with tenfold cross-validation. And you can probably change that. I don't know, I didn't look into it. But and then it will give you the best model. And so the best model, the best linear model here is just linear tune, best model. Okay. So I do that. And then I want to look at, I want to plot this against the training data and see, how well it's doing. Okay, and so here's, here's the line it found that was the best. And so the little circles here, let's zoom in. The circles are, I believe, appropriately classified, and the X's are inappropriately classified data points. And then we have this little table here, and it basically shows us, how often we're getting it right along the diagonal. Predicted blue, it is blue. Predicted red, it is red. And then when it's being misclassified. Okay. Yeah, actually, as I'm looking at this, I don't think that the X's and the O's correspond to appropriately and inappropriately classified observations. I'm actually not sure what those mean. So perhaps somebody could enlighten me in the comments. That would be great. Okay, so that was for the training data for the linear predictor, and now we want to do it for the test data. Okay, so I find my predictions, I get a table, I plot them, and this is what it looks like here on the testing data. Okay. All right. So so now we move to the polynomial classifier. So I have I'm basically doing the same thing, but now for my model, where I am testing different costs, we did that with the linear classifier. I'm also trying different degrees, okay, degree of the polynomial, okay. So we run that, and we get our give it a second here, I guess, okay. We get our classification on the training data, and then also on the testing data. And this is what we get. Okay. And then we'll also do the radial basis function. And so now I have my cost, And no longer am I trying different degrees, I'm trying different gamma values here, okay? And then I find the best model. I find how it did on the training data right here, as well as on the testing data. Okay. And then we can directly compare each of these by looking at the tables of the predictions on the test data. And so you see that for these are just put in the same order that we went through them. So for the linear model, we have a few misclassifications and a few misclassifications as well for the polynomial. And then the radial one seems to do the best, in this particular case. Okay, we'll call that good.